Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for April 27th of 2025 is titled IC 418, the Spirograph Nebula. So what do we see here? Well, this is an example of a planetary nebula, and it's known by its catalog designation of IC 418, also known as the Spirograph Nebula, for the distinct patterns that happen to come within it, as with the similar cyclical drawing tool that is used of the same name. Now, this is an example of a planetary nebula. Despite its name, a planetary nebula has absolutely nothing to do with planets. It is, in fact, the end of life of a star, much like our own sun. And when a star reaches the end of its life, it builds up a core, in the case of the sun, of something like carbon at the center. So that core, that bright object at the center, is the dense core, primarily composed of carbon atoms squashed together as close as they possibly can. Essentially, their electron clouds are touching, and you could not push them any closer together without violating what is known as the Pauli exclusion principle, which states quantum mechanically that two electrons cannot exist in the exact same quantum states. They can't have all identical quantum numbers. And that produces a pressure, an electron pressure, which holds it up against gravity. Now, there is no source of energy any longer. This is just a condensed object pushed together as small as it can be, while still retaining atomic structure, still being made of atoms. And if you squash out all that space in between the atoms, you can take something the mass of our sun and squeeze it down to about the size of Earth. And that's just by squeezing out that empty space between the atoms, not within the atoms yet. That would actually squeeze out even more space, but just between the atoms. So you can imagine how small Earth could become if we were to squeeze out all of the material in between, all that empty space in between the atoms in any object here on Earth. So it becomes a very dense object, what we call a white dwarf star. Now, as that forms, the outer layers are then expelled outward into space, and we see that here in the material surrounding it. And that is the planetary nebula itself. So essentially it becomes a red giant, and eventually the star becomes so large that those outer layers are no longer strongly held enough, and they are expelled outward into space and become the planetary nebula. Now, you might get the sense from this that it doesn't all happen at once, because we can see one big ring around, but there's another denser, bluer one inside, meaning that there may have been a second episode where another layer of material was expelled outward. So the exact process of the planetary nebula is something we still research and try to understand to explain how this works. But we do know that most of the stars in the universe will go through a stage like this. From any star less massive to the sun, and even stars 5 or 6 or 7 times more massive than our sun, will end up going through the planetary nebula phase, leaving behind a white dwarf star, and for a brief time giving us a planetary nebula, something like the Spirograph Nebula that we see today. So that was our picture of the day for April 27th of 2025. It was titled IC 418, the Spirograph Nebula. We'll be back again tomorrow for the next picture, previewed to be disappearing rings. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.